Welcome back, everyone. Today we are tackling CompTIA A+ Core 1, Objective 2.1, Mastering Transport Protocols and Essential Network Ports. We are moving away from physical hardware today and diving into the rules of the road for network data transit. Think of our network as a massive, bustling metropolis. We need to know exactly how traffic gets from point A to point B. Let's look at the rules of the road at the transport layer. Our network has a massive address space with port numbers ranging from 0 all the way to 65,535. We use a process called multiplexing, where the transport layer assigns specific port numbers to different applications so they can all share a single physical network link simultaneously. To move this traffic, we rely on two primary delivery vehicles: TCP, which is reliable and secure, and UDP, which is fast, energetic, and low latency. First up is TCP, the Transmission Control Protocol. Think of TCP as our armored truck. It is connection-oriented, meaning it establishes a formal session before sending any data using a three-way handshake: SYN, SYN ACK, and ACK. It provides guaranteed delivery by assigning sequence numbers to packets and requiring acknowledgements. If a packet goes missing, it triggers a negative acknowledgement, or NAC, for immediate retransmission. It also requires a graceful termination using a FIN handshake to properly close the session. The trade-off for all this reliability? It adds a minimum of 20 bytes of overhead per packet, making it slightly slower. On the other side, we have UDP, the User Datagram Protocol. This is our express courier. UDP is connectionless, meaning it just fires data off immediately without establishing a prior session. It offers best effort delivery. There is no sequencing, absolutely no acknowledgements, and no guarantee your data will arrive. By stripping away all that connection data, it achieves high speed and extremely low overhead. Its ideal use cases are voice over IP, streaming video, simple query protocols like DHCP, and PC gaming. When you're running a nightmare dungeon in Diablo 4 or dodging danger in the Fallout Wasteland, you need those rapid-fire, real-time positional updates that only UDP can provide. To quickly compare, TCP is our connection-oriented armored truck. It is highly reliable, heavily sequenced, requires ACKs, but carries high overhead. UDP is our connectionless motorcycle courier. It is an unreliable, best effort delivery system with zero ACKs, but it operates with incredibly low overhead. Now that we know our vehicles, let's look at their destinations. Welcome to the network metropolis. To help you memorize these for the exam, we've broken the city down into 4 distinct districts: web and directory services, the post office for email, file and network configuration, and remote control. Starting in District 1, we have Domain Name System, or DNS, operating on port 53. DNS is the Internet's phone book. Its entire purpose is to resolve friendly, fully qualified domain names like CompTIA.org into the binary IP addresses that computers actually use to communicate. For fast client queries, it primarily uses UDP, but it will switch to the reliable TCP for transferring larger zones between DNS servers. Also in District 1 is web browsing, where we have an open standard and a secure standard. Port 80 uses TCP for HTTP, the Hypertext Transfer Protocol. It serves up HTML web pages in plaintext, meaning the data is completely unencrypted and highly vulnerable to interception. The secure standard is port 443, using TCP for HTTPS. This uses transport layer security to create a fully encrypted tunnel and authenticates the web server using digital certificates. Rounding out District 1 is LDAP, the Lightweight Directory Access Protocol, sitting on port 389 via TCP. Think of this as searching the corporate roster. Its purpose is to query and update network resources, users, and permissions. It is the primary protocol standard used to interact with X500 directories, most notably Microsoft Active Directory. Moving into District 2, we enter the post office. To send and route mail, we use SMTP, the Simple Mail Transfer Protocol, on port 25 via TCP. It's used by clients to push email to a server, and it routes mail between dedicated message transfer agents. A critical security note for the exam: port 25 is traditionally unsecure, so modern secure message submission often utilizes port 587 instead. To retrieve your mail, you have two choices. Port 110 over TCP uses POP3, the Post Office Protocol version 3. This downloads mail directly to the local device and typically deletes it from the server, making it best if you only ever check your mail from one single device. Port 143 over TCP uses IMAP, the Internet Message Access Protocol. IMAP leaves the mail on the server and intelligently syncs your folders across multiple devices simultaneously, making it the modern standard for phones and PCs. District 3 handles our files and configuration. To auto-assign IP addresses, we use DHCP, the Dynamic Host Configuration Protocol, on ports 67 and 68 using UDP. Its purpose is to automatically provision IP addresses, subnet masks, and default gateways to clients. It uses the DORA process: discover, offer, request, and acknowledge, relying on fast UDP broadcast transmissions where the server operates on port 67 and the client uses port 68. To move massive files around the network, we use FTP, the File Transfer Protocol, on ports 20 and 21 using TCP. It physically splits the labor. Port 21 acts as the control channel to establish the connection and pass commands, while port 20 is the data channel where the actual file bits are transferred. For Windows-specific file and printer sharing, we have a stark contrast between old and new. The legacy standard is NetBIOS over ports 137 through 139 using both UDP and TCP. This is completely obsolete today and poses a significant security risk. The modern protocol underpinning Windows sharing is Server Message Block, or SMB, operating securely on port 445 via TCP. Finally, we reach District 4, Remote Control. For command line access, port 23 over TCP uses Telnet. This is a legacy terminal emulation that transmits shell commands and user passwords in completely unencrypted plaintext. It should be entirely replaced on modern networks by port 22 over TCP, which is SSH or Secure Shell. SSH uses cryptography to securely authenticate and encrypt the connection to your servers and routers. If you need graphical remote control, you use RDP, the Remote Desktop Protocol, on port 3389 over TCP. This is Microsoft's proprietary protocol for operating a remote graphical user interface. It seamlessly sends screen and audio data from the remote host down to the client while transferring your mouse and keyboard input back up to the host. Here is your final IT technician's port blueprint. This visualizes every port and protocol we just covered across our 4 districts. Take a screenshot of this, study it, and lock it into memory. You'll be coding these specific parameters into your upcoming XP Boost interactive modules, and you will absolutely see them on the A+ exam. Thank you for your hard work today.